Hey guys, welcome to the start of an instructional series on performing vintage television alignments. My goal in this series is to present it in as clear and simple a manner as I can. Trying to explain the concepts, the terms, what we're trying to accomplish, and how we can go about accomplishing it. Interpreting alignment instructions that you'd often see in service info, showing you how to hook up the equipment and how to use it, and how to go about actually adjusting the components inside the TV chassis. Now, in this installment, I'm going to be talking test equipment. I'm going to show you some examples of each type of equipment you might want to have and show you what I selected to put on my workbench. If you've been watching my videos, this should look a little bit different to you. I completely cleared off my workbench and pulled out select specific pieces of equipment. Now, I also want to make it clear right up front, there's more than one way to do this. By no means do you have to have all this equipment, and you can certainly use less expensive, more modest equipment. Most of this stuff is overkill. A lot of it, as I'll explain, I got because I got a good deal on it, or I want it for other purposes as well, etc. I'm going to be pulling out examples of some vintage sets and performing alignments on them, and I'll try to demonstrate several techniques to accomplish it. Let's get started. Now let's turn our attention to display devices. Regardless of what you are aligning, working on, be it an amplifier, a radio, a TV, you need some indication of the output signal strength. Now, I've aligned a wide variety of things, and unfortunately, the alignment instructions can vary considerably in what they instruct you to hook up. Sometimes it's a VTVM. Sometimes it's a scope. Sometimes you're feeding it back into your sweep generator. So, let me at least give you my thoughts on what you can use, and I'll show you what I chose to use. So, recently I picked up a second 465. Yeah, there are a ton of scopes to choose from. I chose this for a variety of reasons I went into in the video on that. This one I got very lucky. It seems to work perfectly as is, and the controls feel especially nice. I think this will have very little use. So that is going to be my main scope. Now, when you do a visual alignment, when you are sweeping frequencies, you need an XY type display device. Some scopes, most scopes, have an XY mode, this one included. So that's why I would recommend you get a scope like this. Yes, there are older scopes, less complicated scopes. You don't need 2 channels. You don't need 100 megahertz by any means to do alignment. In fact, one of the points of doing an alignment and detecting the signal strength after the detector is you can use a really low bandwidth display device. But I want to also use this as a scope for all kinds of troubleshooting. This is going to be my main go-to device. However, there are other options when it comes to just using or just an XY display device for doing alignments. One other display option is also made by Tektronix. It is a 604 vector monitor or XY display. Screen looks similar to a scope, a little bit bigger, which is nice for aging eyes. But where'd all the controls go? We don't even have inputs. What can this do and how do you use it? Well, on the back there are 3 BNC connectors for X and Y and Z. X controls the beam movement this way, Y this way, and Z the brightness. So it has no sweep, no triggering, no time base, no vertical attenuator. It's up to you to feed in signals that make sense. You only have controls to center it vertically, horizontally, control the intensity and focus. That's all you get on front. So, but it is a very nice display, and it's very linear. So it's very accurate tracking what you feed in from the back. However, given that it's awkward to set up, if you're going to use something like this, I would say only use it if you have a dedicated area to set up sweep equipment. It's a pain to keep moving the stuff in and out and move your cables around and whatnot. So unless you're really going to be hardcore or you have a really big workbench, I would recommend getting a scope with XY capabilities versus one of these guys. But they are very nice. If you're lucky, you can get one cheap. In the same vein as the Tektronix, but at the more extreme end is this guy. It's a WaveTech 1901 XY display. I looked for one of these for a long time, partly because it has a very large display, which I like because I have a deep workbench, and I did that intentionally, and I know this display is going to be back. Having a large display lets me see it more readily. Also, I tend to use WaveTech sweep generators, and this is part of the same family, and this stuff's all compatible and hooks up together nicely. Also, like to the controls, the inputs are on the front. So here's our vertical and horizontal input. This has a stepped attenuator, variable attenuator. You can go into AC mode, centering, brightness. Nice thing to have if you can find it. What makes these somewhat rare is the actual display CRT. I think it's 9-inch or 12-inch rectangular electrostatically deflected CRT. You don't see those very often. So that's for doing visual alignments. You need something that can take in a horizontal signal and a vertical signal and allow you to center them and scale them so it all fits nicely on the display. I'm sure all you guys have meters, but I'll just quickly show you a couple examples. This is a classic RCA volt-ohmist VTVM vacuum tube voltmeter. You plug this in the wall, it has power. That powers some tubes inside that act as a buffer on the input, making it very high impedance, meaning it does not load down the circuit that you're trying to measure. You don't want to disturb or load down the circuit you're measuring because you're going to alter your readings. But it has a nice analog display so you can see the needle swing, so when you're twiddling your coil slug or trimmer cap and they tell you to peak it, it's nice to see that needle swing and kind of rock it back and forth until you get that peak. They also make FET meters, a little bit newer than this solid state, but also same idea, but only using field effect transistors instead of tubes. And then there are, of course, modern digital meters. This is a classic Fluke 27 military version. I'm sure you've seen this on lots of other channels. Dirt cheap on eBay, fairly indestructible. However, it has a low display update rate, meaning the numbers are going to kind of flash or flicker as you're peaking. That can be annoying and not as nice as a meter. However, it does have a bar graph display on the bottom. Still not the fastest update rate, not as nice as an analog meter, but you can peak watching that bar graph. And it's a versatile device, so I do sometimes just use this. I just keep it handy. This, you have to let it warm up and calibrate it, zero it out and stuff, which, if I'm in a hurry, I just want something to turn on. I can turn on and work, and it works. You can also just use your scope. Of course, you can put that in DC mode after the detector, and you'll see your trace move up and down. You can certainly peak using a scope as well. So what am I going to use? I'm going to go with the 465 for my mainstay scope, and I'm going to put out the 9001 just because it's cool. I don't recommend you look for this because I'll tell you, you're going to have trouble finding one, and they can get a little pricey. 604 is an interesting option if you've got the space for it. Make a nice little dedicated hookup. But otherwise, just get a scope. Get a versatile scope with XY mode, and you'll be fine. For a meter, again, I'm partial to 27 because I've been using it for so many years, and it just works. But I cannot argue against the nicety of having an analog display for peaking. Now let's talk sweep generators. Briefly, it's a device where you can specify a low and a high frequency, and it will generate radio frequency between those two bands, between those two bounds, and go back and forth. So say between 10 and 20 megahertz, and it start over again and again and again and again. It's just like you taking a knob and doing this. And they typically have additional inputs and outputs to drive your scope and to detect the signal and add markers in. A marker is a little squiggle that will appear on the display to indicate along that response curve at this little blip, this is a certain frequency, 10 megahertz, 20 megahertz, 50 megahertz, 45.75 megahertz. So there's kind of two categories of devices, ones that are tailored for TVs and ones that are generic for laboratory type work or the cable TV industry. This Suncor SM152 is dedicated for TV. There's also a B&K 415, which is very nice, but only does the higher 44 megahertz IF. The older devices, I just can't recommend. ICO made a couple sleep gens. The problem with sleep generators, the vintage ones, the older they are, the harder they are to use and to maintain. They will require TLC. You're going to have to calibrate them. You're going to have to live with some limitations. For example, the sleep repetition rate on these old sleep gens, typically they just use the AC line. It's just 60 hertz sine wave, and they're driving the sleep generator with that, which sometimes you want a slower sleep rate, because how quickly you're going between the frequencies, that can affect how the display looks. Sometimes they just have one variable marker generator, and it's just a big knob and you adjust, and it's only going to be as accurate as the last time you calibrated it. Also, the actual sweep mechanism on those old ones, sometimes it's as crude as a motor driving a variable capacitor, and it just spins around. Or it's a speaker voice coil attached to a piece of metal, and that forms one side of the plate of a variable cap, and it vibrates, and that varies the frequency. Those things are not linear. They wear out. Just don't if you don't have to. Even this, as I was unfortunately informed after I played around with it, I thought that these markers were all crystal derived and very accurate. No, they're formed by LC tank circuits. So they do need, each one of these markers needs to be calibrated. Regardless, it still doesn't do everything. There were some TVs use a 22 megahertz IF. I think there's some obscure models use like a 36 megahertz IF, and some used 44. This only has markers for the 44. The B&K 415 does have crystal markers, but it's only geared for the 44 megahertz IFs. In other words, I don't know of any device that will do everything, except a while ago on a forum somebody tipped me off to this magical Hewlett-Packard device. It's a direct digital synthesis sweep gen with a lot of programmable markers that basically can do everything. But they're expensive. They're hard to come by. I don't expect you guys to go out and buy one. So what do I like? What am I going to use? I gravitate towards these WaveTech devices that were geared or made for the cable TV industry. This will sweep from 0 to 500 megahertz. This guy's 0 to 1 gigahertz. And that's the only downside to them, is there's just a sweep width control. And at the max range, it goes from 0 to 500 megahertz. Often we want a much, much, much narrower range, like maybe 15 megahertz to 25 megahertz. Typical 10 megahertz width for sweeping a TV IF is what you'd want. So we're going to have this knob way down at the min range. But even so, with a little fine touch, you can get there. You can get there. These are solid states. This one's from the 70s, this 80s or 90s. You dial in the frequency, the center frequency on this knob. Outer is coarse, inner fine tuning. And this is a very nice attenuator. Outer is coarse, inner is fine. And these are the markers. back then you could order custom plug-in markers, so you could tailor this to whatever devices you'd be working on. Those rarely come up for sale. The standard is you get fixed markers at 1 megahertz, 10 megahertz, 100 megahertz intervals, and then this controls how the markers appear. This is a WaveTech 1002, I think. The only downside to this is the connectors are in the back. The output's in the front, but the connections that go to your scope are in the back. So if I use a scope with this and I build some kind of enclosure for it, I'm going to have to run BNC cables and have them hanging out in the front. And depending on what I'm using my scope for, I have to connect and disconnect. That's a little annoying. Now this guy is a bit newer and has some nifty features. For one, some nice VFD displays showing our center frequency and our output level. They made a 1080 and a 1081. One is a 50 ohm output impedance, one has 75. Pay attention, because you're going to want to match your cables and termination to your device. This is the one I prefer to use, though. The center frequency display is a nice thing to have. Again, though, it sweeps a huge range, so I just barely touch this and I'm jumping up in megahertz. There's no fine and coarse, you just get this. But at least the sweep width has a fine and a coarse. But no visual display of how far I'm sweeping. We used to have 0 to 9 on this side, which is megahertz. So if I go here, I'm sweeping 100 megahertz. If I go on the max, and this is the fine control. And same deal with the markers as this is the 1002, where you get markers at 1, 10, and 100, and that's it. There are typically very particular frequencies for your device, like 25.75 megahertz. You want a marker there. You can't do it with these. What you need to do is have a separate RF generator and feed that in. All these devices have external marker inputs. And this has the jacks all on the front. So my scope in and out and RF out are all in the front. So this is very convenient to use. So whether I'm using my scope or I'm using this device right under it, I can make all my connections from the front. So if I make a custom cubby hole and put these into it, I don't need to get at the back of these devices. Now I included this guy up top just for fun. This is a sweep generator that will do the audio range. It'll go up to 5 megahertz. So if you want to sweep the frequency response of an audio amplifier, you could use a device like this. Not super accurate in terms of the center frequency or the stop or endpoints, but it's a fun thing to have if you just want to do kind of a quick and simple frequency response curve on your amp, and it can do sine and triangle and square wave and ramps and all kinds of stuff. And it's in the same family. They use the same enclosure, so the stuff all plays well together. All the connections are in the front again. Okay, what kind of device can we use to generate that external marker signal? Well, an accurate RF generator. The more accurate, the better. I saved up my money some years ago and bought an HP 8657A. Definitely overkill for just a marker generator, but I bought it to be my all-around RF generator for doing radio work, TV work, experimentation, and so on. It can do 100 kilohertz to 1 gigahertz digital synthesis, meaning it's basically computer controlled. You type in the frequency you want and that's what you get. So I'm going to get 1.00000 megahertz out of this thing right now. Same with the output level. You dial it in. Right now I have minus 10 dBm coming out of it. Now that's the only thing I don't like about this is we don't have any knobs. If I want to vary that output level, I don't have a knob I can turn. I can't vary the frequency with a knob. I have to type it in or use some up-down arrow keys. Okay. But on the other hand, it's very accurate, and it can also do AM and FM modulation, both of which can be very handy for alignment work. For example, I was aligning a Predictus recently, and it said to do 30% modulation at 400 hertz. Well, they have a preset mode for 400 hertz. It's a commonly used alignment frequency, as is 1 kilohertz, and you can dial in your percent modulation. Handy thing to have. I'm not saying you have to run out and buy one of these. They generally go for a few $100 and not so easy to service, but it is a very nice thing to have. You can certainly use an analog RF generator. I used to have an HP, I think it was a 600 up here on a workbench. It's pretty accurate too. That would work just fine as well. Now, the only downside with this for a marker generator is you can only get one marker at a time. So when these have an external marker input and hook it up to this, we could do one marker. There are devices. RCA made one back in the 50s. I think they could do multiple markers on one box with one output signal. Otherwise, if you had several RF generators, you could get a combiner and you could mix the output signals together and feed that into your sweep generator. So it is possible to have multiple markers, but you need multiple RF generators to do it. Now, doing TV alignments is not all about sweep generators. There are absolutely going to be steps where you just need a fixed frequency, 4.5 megahertz, for example, or 10.7 megahertz. Most sweep generators do have a CW mode, like this. You go fully counterclockwise till it clicks. CW meaning continuous wave. It's not sweeping. This sets your output frequency. However, you're going to have one heck of a time dialing in, say, 4.500 megahertz when you just have one big knob with a fine tuning. It's going to be nearly impossible. That's where this also shines. When I want to dial in a specific fixed frequency to peak a coil. There's AM radio, 455 kilohertz. This can also do that. Again, you don't have to have something with this level of accuracy or precision, but it does make life a little bit easier. Next, power supply. Very often for alignments, they want you to disable the AGC, the automatic gain control bus, by applying a fixed voltage to it. Typically minus 3 volts, minus 4.5 volts. In the past, I've just taken some AA batteries and wired them in. You can absolutely do that. However, variable DC power supply is a handy thing to have on your bench. If you're going to work on transistor equipment or anything else that might need a battery eliminator, for example, or you want to power up some solid state device, great thing to have. I picked this up a while ago. It's a classic Hewlett-Packard dual supply. You get 2 independent outputs, 0 to 50 volts, 0 to 1 amp. It's a great little linear power supply. And you can track it, meaning that when it's in tracking mode, if you put one side on 5, the other side will be minus 5, I believe. And you can also limit the output current, and you can monitor current or voltage on either side. So that will be my bias supply. As you'll see with all this stuff, generally what I'm using is overkill, specifically for doing alignments, but I use this stuff for other things as well. So that's that. Let's talk safety. It's very likely some of the TVs you will encounter will have hot chassis, series strung sets. In particular, you need to isolate them from your expensive, valuable test equipment, meaning you want that chassis to be electrically isolated before you connect the ground lead of your chassis to of your test equipment to your chassis and POW. So this is my go-to because it's a combination isolation transformer and variac and circuit breaker and backed up by a fuse. It lets you monitor the output voltage, output current, output power, and with this probe you can check for leakage, meaning the parts that are supposed to be isolated from a hot chassis, you can make sure that they really are isolated for safety's sake. Suncor PR57. There's also a 570, which costs considerably more. Either one is a fantastic piece of equipment. Then there's also a classic vintage device like this RCA IsoTap, where you have both some that are isolated, some not isolated, and instead of a variac, it has a step switch, so you can select different line voltages. No meters, but it'll get the job done. I figured before I push all the equipment back against the wall, I make sure it's actually still working. So, fire up the still generator, put it on 1 megahertz with 65% AM modulation, hooked it up to the 465 scope. Both are working flawlessly. The Vector monitor also working flawlessly. The 1080 Sweep Gen, not so much. I think I mentioned it was flaky. This is what it does when it's flaky. Displays don't light up, controls don't respond, it's frozen. I'll take a quick look inside. Since the displays aren't lighting up, I'm hoping maybe it's a digital problem and not an analog RF problem. Like maybe it's just not resetting the microcontroller properly or something like that. Maybe it's got some leaky caps in the power supply. So what I did do is I pulled out the WaveTech audio sweep generator and our 5 megahertz sweep generator, and that works just fine. And I just put a crazy Lysagius pattern on here just so you can get some idea what this display looks like. It's not quite as bright as I'd like it to be, so there might be a little issue with that, but I have no comparison, so maybe that's just as bright as it's supposed to get. I'm just comparing it to the scope, which gets crazy bright. So it just seems like it should get brighter than that, but it's working, so I'm happy enough with that. So I'll see what I can do with this, but I might very well be replacing it with the older WaveTech for now. Well, that was fun. You haven't seen the workbench look like this. This is sort of what I originally envisioned when I set this up. It's just I hadn't worked on projects in a while, and I was so eager to, and I had a big backlog. I dove right into it and never set up the equipment properly. Now I have. This is kind of what I had originally intended this setup to be like. So let's go through what we've got. We've got the WaveTech 1901C XY monitor. I wanted to use a WaveTech 1080 Sweep Gen, but mine crapped out, so I fell back to my older one, which I believe is a model 1002. Right now I have it, these two tied together, and I'm just displaying markers, which indicate various frequency points. We'll talk about that later. This we may or may not need. It's an audio generator. It's got a lot more features than we would ever need for working on a TV or radio. But just think of this is an audio generator. If you want to test an audio amp, you can inject a signal to the grid of, say, the volume, or of a grid of one of the audio tubes of the volume control, and make a nice clear tone. All right, here's the 465 scope I got recently. Haven't done anything to it. It just works. This is the refurbished HP 8657A I bought some time ago. Right now I'm displaying a 1 megahertz AM modulated signal just to demonstrate how nicely the scope plays with it. Dual DC power supply, just generally a handy thing to have. You can use that to generate your AGC fixed bias voltage for doing alignments. Variac isolation transformer, essential for all sorts of radio and TV work when you have a hot chassis especially. Signal tracer I picked up last year. I haven't actually used it yet, but I may very well, because this is a really neat feature where you can not only trace signals, you can put a probe into various parts of the radio or device you're working on, and it will demodulate and amplify the signal, and you can hear it coming out of the speaker. But you can also use this for a speaker substitution. If you don't have the speaker for your device you're working on, or it's blown, you can hook this up, and with these switches you can set it for all sorts of impedances. So there's a built-in output transformer. So, sorry, not just substituting the speaker, it's substituting the output transformer for a wide range of impedances. It's a really handy thing to have. Suncor VG91 Universal Test Pattern Generator. You can do some alignment stuff with this. This can generate a 4.5 megahertz tone, so you can use this to peak your sound IF, for example. Also generates a bunch of test patterns, one of which is the multi-burst, which you can use to test the frequency response of your set visually on the screen of the TV. We'll talk more about that when we do alignments. And underneath that is a TVA92 TV video analyzer. Now this also has a bias output supply, so you could use this for AGC bias voltage in case you wouldn't need a supply like that, but that's just a handy thing to have, generally speaking. This can substitute all sorts of signals to a TV, like horizontal drive, vertical drive. You can ring a yoke, fly back. In other words, you can test a yoke or fly back for shorted turns with it. You can have a huge output range from 3 volts peak to peak up to 300 volts peak to peak, or audio or video. You can inject into the IF with this. Cool thing to have. So that should cover all of our needs to do a TV or a radio alignment for that matter. One other odd and I picked this up last year as well. It's a Tektronix LC meter. It can go down to measuring like below 1 picofarad or down to around 1 picofarad or 1 microhenry. It's a really nifty device for testing very small values on things. It just works really well. I just thought I'd throw it up here. And the Q standard, we'll talk about that in an upcoming video at some point. That goes with another piece of equipment I picked up last year, nothing to do with alignments. So, there we have it. So, what are we going to do with this next? I have a Predicta pedestal chassis, a 9037 I want to align, and I suppose I could align this 10043 as well. There's similar IFs, but there are some differences. I have a Motorola VT71 that somebody messed up the front end of it. I need to align that. And I've got the Stromberg Carlson TC10 and maybe a Westinghouse. In other words, we have a number of vintage sets to play around with. Some using the 44 megahertz IF, some the older IF, so I think we'll have a good mix of stuff to look at. But for now, that is the overview of equipment. I don't necessarily suggest that you run out and try to get exact matches to what I have, because I think you'll have a very hard time doing it. I got lucky with some of these. Some of these took me a long time to find, as I mentioned earlier. But this is the kind of stuff you might need. A signal generator, not you might need, you would need a very accurate RF generator, some type of display device, some type of sweep device, and an output meter, or you can use a scope. All right, that is it for now. Hope you enjoyed this overview of test equipment.